Okay, so our next topic of conversation is the standard algorithm. Why do we call it standard algorithm, and how does that connect to what kids already know coming into this grade and this particular content? So first of all, let's see what kids already know when they come into this this particular lesson. So let's take an example of 147 plus 195. And we'll go over here and we'll say 147 plus 195, and let's model that. So we have 100, 2, 3, 4, 3, 4, 5, 6, 7, and 195. 2, 3, 4, 5, 6, 7, 8, and 9, and 1, 2, 3, 4, 5. So is this correct? 147 and 195. All right. So if we are students and we are just looking at how we might be able to write this number after the addition, we could say this is 200. Now this will add up to 13 rods. And when we have 2 rods, we say 20, or 4 rods, we have 40. So it could be 13t. 13t. And then here we have 1, 2, 3, 4, 5, 6, 7, 12. So we could write this number, or say this number, as 213t12. 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 That is mathematically true. However, it's not in line with our place value. We can't say 213t12. We have to make sure that anytime we can regroup tens, we actually do that. So let's see what we can do by rewriting this number using the base 10 notation. So I could say that these 10 singles could actually be traded into a single rod. So good. Now I have, instead of this 213t12, I have 214t2. 214t2. That's better. This is still a problem though with this, with the 14 tens. So let's see if we can make group those guys too. So 5, 6, 7, 8, 9, 10. So that's 10 of them, and let's make that into a flat. So now what we have is we have 342. So now what we have is 342. And that is our answer in proper place value notation. So let's see what we did. If we write this out, and we have 147 plus 195. We actually said initially that we had 200, right? And then we said that we had 13t, or 130 if we are a little bit more correct, and 12. And then we regrouped this and actually organized it into 342 and added it up into 342. So this writing looks like the standard algorithm, but it's not. It's actually called a partial sum algorithm. Partial sum. It's longer than the standard algorithm, but it aligns much better with what's actually happening on the base 10 block, with the base 10 blocks with the place value. Now, let's go back to our standard algorithm and see what happens with that. So if we have 147 plus 195. Now, let's look. So in the standard algorithm, we go from right to left. Why? Why right to left? Is a good question. Because really, if I want to add a little over 100 and almost 200, I really want to know how big that's going to be, not the fact that I'm going to have two singles on the end, right? So I'd really like to know the magnitude of that number first and not work on the least consequential numbers first. But anyway, standard algorithm says from right to left. And we say 7 plus 5 is 12. And we say that's 2, carry the 1. Carry the 1. Why do we carry the 1? Is it a 1? It's not a 1. It's actually a 110. It's a rod. And what is this carrying? We're not carrying, we're regrouping. So it's actually not a 1. It's a 10. And we're not carrying, we're regrouping. Let's go on. Now we're going to add 4 and 9 and 1. Right? Add 4, 9, and 1. Are we actually adding 4, 9, and 1? Well, no, we're not. We're actually adding 40 and 90 and 10. Children do not understand. If they have a good concept of place value, they don't understand where these 1 and the 4 and the 9 are. In order to make them connect to what they already know, then we need to be looking at 10 plus 40 plus 90. And then what we say is that that's a 4, carry the 1. Oh my goodness. So let's try this again. So that's 4, carry the 1. Well, let's look at this. Is this a 4? No, it's not a 4. This is actually a 40. What is this carrying thing? And what is the 1? The 1 is actually not a 1. It's a 100. And carrying is not carrying, it's regrouping. All right, let's keep going. So then we say 1 plus 1 plus 1 is 3. So we say 1 plus 1 plus 1. And again, notice that that's not 1, and neither of those are 1. They're actually 100 plus 100 plus 100. And it's not a 3. It gets us 300. All right. So do you get the idea that when we are using the language of the standard algorithm, we completely remove ourselves from everything that the kids would have learned up to that point? There's nothing wrong with writing it the way we write it. It's just the way we talk about it. So let's write the standard algorithm. Even if I'm not going to be doing partial sums, let's write the standard algorithm. And the way that we would normally write it, but I'm going to say it in such a way, I'm going to do a narrative in such a way that it connects to what the kids already know. So I'm going to, and I'm just for the sake of doing it the same way as the standard algorithm, I'm going to go from right to left, even though it's not intuitive. So 7 and 5 is 12, so that's 2 1s and 1 10. 10 and 40 and 90 is 140, so that's 4 10s and 1 100. And 100 and 100 and 100 is 300. Now notice I wrote exactly the same thing that I wrote up above, but now it actually makes sense as to what I'm doing and where these numbers are coming from. So when we're talking about the standard algorithm, it's not the writing. The writing is just fine. It's the narrative that we need to be very careful about. So you can work your way through these problems and make sense on this page and make sense of the questions and how they connect to what we already spoke about, what I told you about with a standard algorithm.